Imagine waking up to a sky you don't recognize, a sun that's either a searing inferno or a distant pinprick. The very ground beneath your feet groans, and the air you breathe transforms into something alien. For the first time in human history, Earth moves. Not just a wobble, not a gentle shift, but a complete cataclysmic exchange. We've traded places with another world, embarking on a journey through the solar system's most extreme environments. In this video, we'll discover what happens to our planet and to us if Earth were to swap orbits with every other planet in our solar system. Prepare to witness the breathtaking fragility and immense value of our home as we travel from the blistering furnace near the Sun to the frozen shadows beyond Neptune. Our journey begins with a terrifying jolt as Earth finds itself at just 58 million kilometers from the Sun. This is 3 times closer than our familiar orbit, a proximity that immediately redefines everything we know. A year would shrink dramatically to a mere 88 Earth days, a dizzying rush around our star. But the true horror lies in the Sun's immense gravitational pull. Tidal forces would relentlessly slow Earth's rotation, stretching a single day to last longer than an entire year. One side of our planet would become perpetually locked in a searing embrace with the Sun, roasting under temperatures exceeding 450 degrees. This is hot enough to melt lead. On the opposite side, plunged into eternal night, temperatures would plummet below 180 degrees. The atmosphere, unable to withstand such extremes, would begin to burn away within weeks, stripped by solar winds and intense radiation. Our vast oceans, the cradle of life, would boil violently, evaporating into space and leaving behind vast, shimmering salt deserts and scorched, cracked stone. The very crust of Earth would buckle and groan under this unimaginable thermal stress, triggering widespread volcanic eruptions. On the night side, oxygen itself would freeze, falling as glittering, deadly snow that never melts. The boundary between day and night would become a perpetual, violent storm front, where superheated air clashes with supercooled air, generating winds that tear across continents at speeds of 1,000 kilometers per hour. No life as we know it could possibly survive this hellish transformation. Mercury's orbit would swiftly turn Earth into a half-molten, half-frozen corpse, a monument to cosmic indifference. Humanity would last mere minutes, perhaps hours, before succumbing to the unimaginable conditions. We must move outward, quickly, before our planet completely disintegrates. Our next destination offers a brief, deceptive reprieve as Earth settles into Venus's orbit, 108 million kilometers from the Sun. Here, sunlight is almost double what we currently experience, a seemingly manageable increase. A year would now last 225 Earth days, a slightly quicker pace than our own. However, this extra heat would trigger a catastrophic, runaway greenhouse effect, a grim echo of Venus's own fate. Within mere centuries, our beloved oceans would vanish, evaporating into the atmosphere and thickening it beyond recognition. The atmospheric pressure at the surface would soar to 90 times greater than on current Earth, crushing everything under its immense weight. Carbon dioxide, released from the boiling oceans and burning biomass, would trap every single ray of sunlight, turning our planet into an inescapable oven. Temperatures would relentlessly climb past 460 degrees, hot enough to melt many metals. The sky would be perpetually shrouded in thick, corrosive clouds of sulfuric acid, raining down a deadly, acidic mist that never reaches the ground, evaporating midair. The land itself would glow a faint, ominous red beneath a perpetual yellow sky. Even humanity's most resilient underground bunkers would ultimately fail, as the surrounding rock itself would grow hot enough to deform and collapse. Venus's orbit would transform Earth into a suffocating, crushing pressure cooker, a world where life ends not in fire, but in breathless, inescapable heat. We must seek colder climes, a sigh of relief perhaps, as Earth now finds itself 228 million kilometers away from the Sun, in Mars's orbit. Here, our planet receives only 43% of its usual sunlight, a stark contrast to the previous infernos. A year would stretch to a lengthy 687 Earth days, giving us more time to adapt, or so we might hope. The average temperature would plummet to a frigid 60 degrees, turning our familiar world into a vast, icy expanse. The sky would dim to a pale, ethereal orange, and our magnificent oceans would freeze solid, forming colossal continents of ice. The air pressure would collapse, thinning dramatically, and snow made of carbon dioxide would drift silently over what were once vibrant forests. Only near the equator might liquid water briefly appear for a few precious hours each summer, but for the most part, the planet would become a desolate desert of frost. Civilization would be forced to retreat deep underground, warmed by geothermal energy or nuclear reactors, sealed within pressurized domes. Outside, colossal dust storms powered by thin, biting winds would rage for months on end. Radiation from space would become a far greater threat, as Earth's magnetosphere would weaken significantly when its core cools in this distant orbit. Earth in Mars's orbit would still be home, but barely. Humanity could endure here for centuries, a testament to our resilience, but only as a frozen, struggling shadow of its former self, forever gazing at a diminished sun. Our journey takes us even further into the cold, to Jupiter's orbit, 780 million kilometers from the Sun. Here, sunlight is a mere 4% as bright as we know it, a faint memory of our home star. A year now lasts a staggering 12 Earth years, an eternity for those who remember warmer days. The temperature would plunge to an unimaginable 150 degrees, and our atmosphere, already thin, would begin to collapse entirely. Our oceans, long frozen, would expand as they solidify, exerting immense pressure that would crush continents beneath their weight. Vast ice sheets, kilometers thick, would reflect the faint sunlight, making the planet even colder, a world of perpetual twilight. But a new, terrifying danger emerges: asteroids. Jupiter's orbit lies perilously close to the asteroid belt. Without Jupiter's immense gravitational pull to shepherd and deflect these celestial wanderers, countless rocks would now cross Earth's path. Massive impacts would pepper the surface with terrifying regularity, each one capable of wiping out entire cities or even continents. Within a few decades, our planet would become a frozen battlefield of craters and ice, a testament to cosmic violence. Humanity would survive only in deeply buried habitats, powered by advanced fusion technology, clinging to existence. The stars would shine with an unnerving sharpness and brightness in an endless, frigid winter sky, a constant reminder of our precarious position. Further still, we venture into the deep cold of Saturn's orbit, 1.4 billion kilometers from the Sun. Here, the light from our star weakens to less than 1% of what we know, a mere glimmer in the vast darkness. A year stretches to an almost incomprehensible 29 Earth years, a lifetime for many. The average temperature plummets to 103 kD. The air, already thin, turns still and silent. Nitrogen and oxygen, the very gases of life, begin to liquefy, forming strange, shimmering pools. The seas are now frozen mountains, colossal structures of ice. Clouds vanish entirely as there simply isn't enough energy left to lift them. Without sunlight, the very engine of life, photosynthesis, would cease. The intricate food chain would collapse instantly. The last plants would freeze solid, and the last animals would starve, their cries swallowed by the profound silence. Only isolated underground colonies, powered by nuclear heat, could possibly persist, tiny pockets of warmth against an overwhelming cold. Saturn's orbit would transform Earth into a crystal sphere, wrapped in a thin, ethereal haze, its surface glittering like glass under a dim, golden sun. It would be beautiful in its desolation, utterly silent and profoundly, irrevocably dead. Now, almost 3 billion kilometers from the Sun, in Uranus's orbit, 1 year would last an astonishing 84 Earth years. The Sun, once our life-giving star, would shrink to a mere bright star in the inky blackness, barely distinguishable from the countless others. Temperatures would plunge to an unimaginable 220 degrees Celsius. Air molecules would move so slowly that sound itself would fade into nothingness, swallowed by the extreme cold. The ocean, long frozen, would become a solid, unyielding mass, and the atmosphere would collapse entirely. Even nitrogen, a common gas, would fall as snow, blanketing the landscape in strange, alien drifts. Our planet, now in Uranus's peculiar orbit, would tip dramatically on its axis, creating decades-long seasons. Imagine 40 years of dim, perpetual twilight, followed by 40 years of absolute polar night. During the long twilight, faint auroras might shimmer weakly above frozen clouds, a ghostly dance of light in the profound cold. Human survival here would be an almost impossible feat, possible only deep underground, clinging to geothermal heat sources. But the surface would be utterly still, a frozen Earth turning slowly, silently beneath a distant, indifferent sun. Our journey culminates at the final frontier, Neptune's orbit, a staggering 4.5 billion kilometers from the Sun. Here, 1 year lasts an almost inconceivable 165 Earth years, a span of time that dwarfs human existence. Sunlight here is barely a whisper, a ghost of its former self. The temperature falls below 230 degrees, a cold that defies comprehension. The air itself would solidify, turning into a strange, brittle substance. Oxygen, nitrogen, even carbon dioxide would freeze into layered crystals, forming alien landscapes of solid gas. Yet, paradoxically, fierce winds would roar at over 2,000 kilometers per hour, faster than any hurricane in recorded history. These superfast winds, driven by the extreme temperature gradients, would scour the surface with shards of ice, reshaping mountains into smooth, polished plains. The ocean, long frozen, would become stone, an unyielding monument to the cold. Earth would transform into a frozen jewel, stunning from the vastness of space, but utterly lifeless up close. No warmth, no air, no dawn. Just an eternal, profound silence that could last forever. 7 orbits. 7 vastly different destinies. Our incredible journey through the solar system's extremes reveals a profound truth. Too close to the Sun, we burn. Too far, we freeze. Only here, at a precise distance of 150 million kilometers, do we balance perfectly, miraculously between fire and ice. Our familiar 24-hour day, our comforting 365-day year, our gentle, life-sustaining seasons, all are products of this incredibly fragile, perfect distance. Move it even slightly and our oceans boil away or vanish into solid stone. Our atmosphere either ignites or collapses. Life, as we know it, simply ceases to be. Perhaps the real question isn't, what if we changed Earth's orbit, but rather, why are we exactly where life can exist against all cosmic odds? We are balanced on a knife edge of physics, a delicate equilibrium that is everything. This journey should fill us with a profound sense of wonder and an urgent appreciation for the precious, unique home we inhabit. As for the other planets now orbiting where Earth once was, that's a story for our next video, a tale of their own cosmic transformations. If you made it to the end of this incredible journey, take a moment to truly appreciate our home. Hit that like button to help more curious minds discover this cosmic perspective. Subscribe and ring the bell to join our community of explorers, and get ready, because next time we'll see what happens to them when they come to us. Let's cherish and protect this extraordinary blue marble we call home.